All right, so this is the Chapter 9 practice test review key. So starting with question 1, it asks us to graph the function y equals negative 2x squared plus 8x minus 6. Before we can graph it, we have to find some of the key information. Like we have to find the axis of symmetry, identify our vertex, then it always helps to have our y-intercept and plot those points to see what we can find. All right, so let's start with the axis of symmetry. Remember, to find the axis of symmetry, we're going to use the formula x equals negative b over 2a. And so looking at our equation, our a is negative 2, b is 8, and c is negative 6. So right off the bat, that tells me I need negative 8 divided by 2 times negative 2, which is a negative 4. So our axis of symmetry is just 2. So our answer here should be x equals 2. Then remember that value for axis of symmetry is also the x value of our vertex. So this is 2. And to find the y value of our vertex, all we have to do, plug that value back in to the original equation and solve for y. So negative 2 times 2 squared plus 8 times 2 minus 6. In this case, I think we get 2. So the y value here would just be 2, which means the y value of our vertex is also 2. So we currently have our vertex as the point 2, 2. So we can plot that first. So this will be our vertex point. All right, and then from this information, we also know that our y-intercept value is negative 6, which we can use to help graph this. Remember, through your vertex runs your axis of symmetry, so to help me graph it, I'll draw that in here. And so I'm going to plot my y-intercept. It's negative 6. So 0, negative 6 is down here. And because of the axis of symmetry, I can mirror it across. And I have a point here as well. Just from the general shape of this graph, I currently know it's going to be a maximum. And then it wants us to circle the solutions on the graph. Well, in order to figure out what those values are going to be, this is where your graphing calculator would come in handy. You would put the equation on the y equals screen, then hit second graph and see the table. And you're essentially looking for any time the values for y are 0. And so I know one of those points. Let's say I wanted to find the value for y when x was 1. If this is the case, if I plug 1 in for x in the equation, or if I look at my table, I get that my y value would be 0. So that means I have a point here on my graph. And I can mirror it over my axis of symmetry to right here as well. So this is the general shape of my graph. I found the point 1, 0, and I also found the point 3, 0. And those represent my x-intercepts, which we also know to be the solutions to our graph. So we'll circle those. And down here, we'll say our solutions are x equals 3 and x equals 1. And so that's it for question 1. We'll move on to question 2. A ball is thrown into the air. Its height, h in feet after t seconds, is given by the function h equals negative 16t squared plus 40t plus 3. How long does it take the ball to reach its max height? Well, this is time to max height, and we talked about this in class. Anytime you're looking for time to max height, you're essentially looking for the x value of the vertex or the axis of symmetry. So we're going to set up the axis of symmetry, negative b over 2a. So it's negative 40 over 2 times negative 16. In this case, we get 1.25 seconds. So it takes the ball 1.25 seconds to reach its max height. Then it wants to know what the maximum height will be. Well, we plug that value back in for t and evaluate for h. So h equals negative 16 times 1.25 squared plus 40 times 1.25 plus 3. If you plug this exactly like this into your calculator, you should get the answer you need back, which will be 28 feet. So it takes 1.25 seconds for the ball to reach its maximum height, and the maximum height will be 28 feet. In questions 3, 4, and 5, we are asked to solve using square roots. So that means we have to isolate our squared variable. So in question 3, the first thing we want to do is subtract 79 from both sides. And we get 8x squared equals 2. We'll divide by 8. We get x squared equals 1/4. And then we square root both sides. And remember, with square rooting, you get two answers. So I'm going to get positive, negative, and the square root of 1 is 1, square root of 4 is 2. And so this is my answer. Question 4, same idea. I'll subtract 34 from both sides. I've got 7x squared equals 1,372. I'll then divide both sides by 7. I get x squared equals 196. Then I need to square root both sides of the equation. When I square root both sides, remember I'm going to get positive, negative, and I get a plus or minus 14. So positive, negative 14 is my two answers. Then I move on to question 5. Well, question 5, I'll subtract 48 from both sides. In this case, I get x squared equals a negative 36. When I try to square root here, however, I cannot square root a negative number, so I get no solutions. Questions 6, 7, and 8, we're solving by factoring. So in question 6, we have a leading coefficient of 1. So we're just looking for two numbers that multiply to give us 24, but add up to be negative 11. Well, that's x minus 8 and x minus 3. At this point, I'm going to set each quantity equal to 0 and solve. So I'll add 8, and I get x equals a positive 8. And then I'll add 3, and I get x equals a positive 3. So my two answers are, well, z, sorry. I changed the variable. My two answers are 8 and 3. Question 7, I have a leading coefficient, so I have to use slide, divide, factoring. So I'm going to take my leading coefficient of 3, and I'll slide it back. I've got x squared minus 5x minus 36 equals 0. Factors of negative 36, that give me negative 9. Well, that's going to be x minus, or negative 5, sorry. It's going to be x minus 9 and x plus 4. But now I have to divide by my leading coefficient. If it divides evenly, divide it. So x minus 3. If it does not, you have to bring it back out in front. So that gives me, let's see, 3x plus 4 equals 0. We're going to set each of these equal to 0 and solve. So x minus 3 equals 0, 3x plus 4 equals 0. So that means on the left, I'll add 3 to both sides, and I get one answer is x equals a positive 3. On the other one, I have to subtract 4 from both sides and then divide by 3, and I get a negative 4/3 as my other value. So my two answers are 3 and negative 4/3. Question 8, very similar. You're solving by slide, divide, factorization. So I'm going to take the 2 and I'm going to slide it back. So I've got x squared plus 7x minus 60 equals 0. Factors of negative 60, that give me a positive 7. Well, that's going to be positive 12, negative 5. So x plus 12, x minus 5 equals 0. Divide by your leading coefficient, which is 2. If it divides, go ahead and divide it. So that's x plus 6 now. The other one becomes 2x minus 5 equals 0. We'll set each equal to 0 and solve. So x plus 6 equals 0, and 2x minus 5 equals 0. For the left equation, we subtract 6, so we get negative 6 is one value. For the right one, we'll add 5, and then we'll divide by 2. So we get a positive 2.5, or 5/2. So these are my two values of x. Question 9 and 10 ask about the discriminant. And remember, the discriminant is that equation that's a part of the quadratic formula, which is the b squared minus 4ac. It's the part under the square root. And we can use this to determine how many real number solutions an equation should have. So let's look at question 9. We know our a value is -1, b is 4, and c is -4. So we'll plug this into the discriminant. So that's 4 squared minus 4 times -1 times -4. Here we should get a discriminant equal to 0, which means we have one real solution. We'll do the same thing in question 10. We know our a value is 1, b is 3, c is 2. So we've got 3 squared minus 4 times 1 times 2. This time our discriminant is going to be a positive 1. Since it's a positive number, that means we have 2 real solutions. Had our answer been negative, we would have no solutions, but since it's positive, we have 2. All right, now we have to look at questions 11 and 12. They want us to use the quadratic formula. Remember the quadratic formula? X equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. So starting off, we know our a value is 3, b is 4, and c is -4. And so we're going to plug this into the quadratic formula. So x equals -b would be -4 plus or minus square root of 4 squared minus 4 times 3 times -4, all over 2 times 3. So as we go along simplifying this, we get -4 plus or minus the square root of 64 over 6. The square root of 64 is 8, so I've got -4 plus or minus 8 over 6. So now I have my two equations I can set up. I've got -4 plus 8 divided by 6. Well, that's a positive 4 divided by 6. So that'd be 4/3, or 4 over 6, or 2/3. So there's one answer. Then we've got -4 minus 8 over 6, which is -12, divided by 6, which would be -2. All right, let's look at question 12. Same idea. We know our a value is 2, b is 10, c is -12. So we've got x equals -10 plus or minus the square root of 10 squared minus 4 times 2 times -12. All of this over 2 times 2. So underneath the radical, we can simplify that down to, or the square root. Under the square root simplifies down to 196 over 4. So the square root of 196 is 14. So we've got -10 plus or minus 14 over 4. We can create our two equations. We've got -10 plus 14, which is a positive 4 divided by 4, which gives us an answer of 1. Then we've got -10 minus 14 divided by 4. So -10 minus 14 is -24. -24 divided by 4 is a -6. And so those are our two solutions. All All right, so last problem. Mr. Pelzer crumpled up all the bad tests and threw them as high and as far away from him as he could. The height h if the paper in feet after t seconds is given by the function h equals negative 16t squared plus 144t plus 4. All right, and this asks, how long does it take the paper to reach the maximum height, and what is that max height? So here they're essentially just having us find the vertex. And remember, to start finding the vertex, the first thing we want to use is x equals negative b over 2a. So let's see, time to max, we're going to say 144, negative 144, so it's negative b over 2 times negative 16. And we should get 4.5 seconds is how long it takes the paper to reach its max height. Then, to find the max height, or to find the actual max height, we plug this back into that equation. So h equals negative 16 times 4.5 squared plus 144 times 4.5 plus 4. And so we're going to evaluate this for h. So if we evaluate this for h, we get the maximum height of the papers to be right around 328 feet. This doesn't seem like a very realistic problem. Paper generally doesn't go that high unless it's really heavy, or in this case, somebody's really strong throwing it straight up, but we'll go with it. And then the last part says, how far have the papers traveled when they hit the ground? All right, so we're trying to find the x-intercepts. And so one way to do this would be graphically, or we can simply just use the quadratic formula. So quadratic formula says x equals negative b, so negative 144 plus or minus square root of 144 squared minus 4 times negative 16 times 4 all over 2 times negative 16. So as we simplify this, underneath the square root, we get, well, we have negative 144 plus or minus the square root of 20,992 all over negative 32. Then we can find this. We find out that the square root of 20,992 is 144 point, let's say 0.9. So we've got negative 144 plus or minus 144.9 over negative 32. We'll create our two equations. We've got negative 144 plus 144, plus 144.9 over negative 32. Well, that gives us a positive 0.9 divided by a negative 32, which is actually going to give us a negative answer. So we don't actually want that one. So let's look at the other option. We've got negative 144 minus 144.9 divided by negative 32. So negative 144 minus 144.9 gives us negative 288.9. Then we divide that by a negative 32. And we should get that it takes right around, or takes about 9.2 seconds is the value for x, or 9.02. So we get our x-intercept is at 9.02, or right around 9. And so this is the answer that we're looking for. We don't want the negative value.